Hi, I'm Scott Rocco, Application Engineer from Siglent Technologies, America. Today I want to demonstrate Siglent's pulse generator technology called EasyPulse. It has the capability to generate a pulse signal with a fast rising and falling edge, a very small duty cycle, and low jitter. Now I want to show you a demonstration. While outputting a low frequency pulse, EasyPulse provides a rapid rising edge and trailing edge versus an ordinary DDS pulse edge, which is very slow, in the microsecond range. The edge of the EasyPulse wave can be adjusted over a larger range. When generating a 10 Hz pulse waveform, the minimum falling edge can be set as low as 6 nanoseconds. But an ordinary function generator cannot achieve transition times this fast on either the rising or falling edge. In this example, we're outputting a 10 Hz waveform. And now we can change the leading edge transition time, and as we can see, the minimum time is limited to 200 microseconds. And now we can change the trailing edge. It is also limited to 200 microseconds. Channel 1 of this oscilloscope is the output from Siglent's STG5000, and channel 2 is from the other generator. Now we can change the time base to find the rising edge. Here we can see the difference between the Siglent generator using the EasyPulse technology versus the other generator. Notice the fast rising edge time compared to the slower rise time of the other generator. Okay, now let's change the falling edge. And here we will see the same results. Now let's view another waveform on the oscilloscope and change the transition time from 6 nanoseconds to 79 milliseconds. Here we can see the difference. Now we will change the falling edge. We will also change the falling edge from 6 nanoseconds to 79 milliseconds. Setting the other function generator to an output frequency of 10 Hz and a duty cycle of 50%, adjustment range for the rising and falling edges is smaller than on the Siglent. Here you can see the minimum is 200 microseconds, and we could change it to a maximum of 1 millisecond. Let's look at the waveform on an oscilloscope. Our transition time is 6 nanoseconds. We will now change it to 79 milliseconds. And now we'll change the falling edge. We see the same difference as the leading edge. Now we'll check the waveform on an oscilloscope again. The time base is set to 200 microseconds per division. Now I'll change it to 1 millisecond per division. As you can see, there's almost no change in the waveform. The duty cycle of EasyPulse can be as low as 1 part in 1 million, but the pulse width of a normal DDS generator is large and the duty cycle cannot be set as nearly as low, as we see in the STG5000. Now we see the other ordinary DDS compared with Siglent's SDG 5000. I will enter a low duty cycle waveform on the other generator, and you will see we will get a limit error. The difference between Siglent's and the other ordinary DDS. Using our oscilloscope to measure the cycle-to-cycle jitter of the Siglent generator with EasyPulse, the Siglent jitter is measured as 100 picoseconds. Now let's output a frequency of 10 megahertz, and the standard deviation value is measured as about 80 picoseconds.